Welcome, calculus students. This is the first of 4 videos on the FRQ practice assignment. So I will be doing each question just on separate videos. So we've got question number 1. We have a picture, graph of f. Then we have our question stem. Let f be a function defined on the closed interval from 0 to 7. The graph of f, consisting of 4 line segments, is shown above. Let g be the function given by g of x equals the integral from 2 to x of f of t dt. First thing we're asked to do is on part A, we're asked to find g of 3, g prime of 3, and g double prime of 3. So I'm going to be doing this on paper. Not this paper because there's not enough room. So we've been asked to find g of 3, g prime of 3, etc. So I'll be writing on another piece of paper. That way I can keep the graph there on the picture and the question stem, but not have to try to just manipulate everything. So g of 3 will be equal to the integral from 2, and we were replacing x. We replaced x with 3, so we're going to replace x with 3 of f of t dt. Okay, that means we need the integral from 2 to 3, or the area under the curve from 2 to 3. So looking at my picture from 2 to 3, I'm looking for this area, which is 1, 2, and I think 3. I think those two squares make 1. We'll just double check. We've got a triangle. Base of 1, height of 2. So base times height, which is 2, divided by 1/2 times 1/2. Anyway, either way, it's still 1. So that is equal to 3. And that's how I found it. I just found this area right there. 1, 2, and those two make another one, so 3. No big deal. Next, we're asked to find g prime of 3. Now, that means we need g prime. So to find g prime, given that I need to write that down right here. Okay. So to find g prime of 3, I need to find the derivative. So g prime of x is equal to the derivative of this, which, as we recall from class, is f of x. Today we learned that if we take the derivative of an integral expression, it doesn't matter what this number is, it'll always be the function evaluated at the higher endpoint. Okay? So this is a graph of f. Okay? And I'm looking for g prime of 3. So at 3, the graph is at 2. So g prime of 3 is equal to f of 3, which is 2. Just reading the graph, no big deal. Then we've got g double prime of 3 is our last thing I'd ask for. So we've got g of 3, g prime of 3. Now we want g double prime, so we're going to take this second derivative. So second derivative, g double prime of x is equal to f prime of x. And so we want to know the derivative of f at 3, which is the slope of the line, and the slope is -2. So again, what I did is the first one, I just took the integral from 2 to 3, which meant area under the curve. Which just meant I calculated a quick area. Then for g prime of 3, I took the derivative of my function, which was the inside function evaluated at the higher endpoint. So I took the derivative. And so then I just read the graph at 3. Now, for g double prime, I took the second derivative. So I took the second derivative of the original function. So there's my first derivative, there's my second derivative, so that meant I was reading the slope. Red slope of graph at x equals 3. Okay, so that's part A. No big deal. Part B says, find the average rate of change on the interval from 0 to 3. So there's a lot of different ways. This is actually a really simple question we don't know how to answer yet. So we're going to answer it in a complicated way with what we know right now. So right now, we know average rate of change. You can't see that. We know average rate of change is f of b minus f of a all over b minus a. Okay? That's average rate of change. So it wants the average rate of change from 0 to 3, which means I need f of 3, which I already have, f of 0, which I don't have, average rate of change of g, excuse me. Average rate of change of g means that I'm going to be doing g's instead of f's. So g of 3 and g of 0. I know g of 3, I found it in part A. I do not know g of 0. Okay, so g of 3 is 3. G of 0 will be the integral from 2 to 0 of f of t So again, I'm replacing x with 0. Now this is a little tricky, but basically I'm finding the area from 2 to 0. But since I'm going this direction, I'm going from left. So I'm not going this way, but when I was going from 2 to 3, when I'm going from 2 to 0, it's going to be the opposite sign. We haven't talked about that yet. Okay, but the area is 1, 2, 3, 4. For the same reason that this was 1, this is 4. But since that's the regular area, that's the area from integral from 0 to 2 of f of t dt is equal to 4. So the integral from 2 to 0 is negative 4, and that's weird. And again, we haven't really talked about the rule that helps us to know that, except for that we're going the opposite direction, so it's going to be the opposite sign. We can live with that for now. So now I have everything I need to find the average rate of change. By the way, there's a way faster way to do this, just so you know. But anyway, I get g of 3 minus g of 0 all over 3 minus 0, which is 7 over 3. So that's my average rate of change. All right, now we're on to part C. I'm going to move this forward. Part C says, how many values is value C, where C is between 0 and 3, where the derivative of C is equal to the average rate found in part B? So our average rate of change is 7/3. Okay. So we want to know how many places is okay, so equal to 0 or undefined. I forgot that undefined part. Sorry about that. And so when I look at this, also the other thing that happens is the derivative would change signs. And so that happens at 2 and 5 because the second derivative is undefined at these 2 points. And the slope is positive, then the slope is negative, the slope is negative, the slope is positive, the graph changes sign. So those are my 2 answers. X equals 2 and 5 because f prime of x changes signs. At x equals 2, it goes from positive to negative. And at x equals 5, f prime changes from negative to positive. Okay, that's it. All right, good luck. I'll see you again soon.